All right. So what we talked about earlier is that the MapReduce is basically a very highly customizable version of group by, right? The examples that we took and things like that. So instead of writing a query, you write the logic, and that's what makes the group by. Okay, question from David. Could not attend Thursday's session. And where do I find the recording? Let me also check if it is available somewhere. I think it was uploaded here. Okay. Though the silence is not removed, so you might have to jump back and forth, okay, to see. Okay, I think this is the right URL. Okay. Also, it should be available in your, my courses. Okay. Okay. In my courses, is it available inside the recordings towards the last? I think this is the one. Okay, let me just take a look. Yeah, it is there. Great. All right, so that was how to access. I'll just open one more window. Okay, now this window we'll use for presentation and the other window we'll use for general hands-on. Okay, so this window for hands-on. Okay, now, so this is clear to everyone, right? Any questions at this point? Okay, a question from Robin: was the QA chat included in the recorded version? Let me put two things there. Okay, on my to-do. Okay, add chats to the session. Second is add. Okay, add chats to the session. What else was there? The add document to the session. Okay, these are the third March. Okay, that's my to do. Try the second link. This one. Did it work? I think it's getting processed or something. Okay, cool. So which class was Thursday's recorded appended to? I'll just show you. So if you go into CloudxLab /courses.my, you can see here there is BDHS here. This one has, and probably this is the one. Isn't it available everywhere? Yeah. So there are two courses, one this, okay, and other this. It should be available in both of them, okay. Are these not available? Are either of these are not available to you? Either this or this. Okay. Okay. Another question is, um, when is the last day of the session for the students enrolled for Big Data with Hadoop? Actually, the course has extended by a week because we had great set of questions. So uh, when you go here, go back. So okay. So let me first answer my question. So David, don't you have access to BDHS ILT Jan 28 or BD Big Data with Hadoop ILT Jan 2018? Neither of them. Oh, let me just take a look at it because last time I had fixed this. Okay, add David to. Okay, all right, great. Let me just, after the session, I'll take a look at it and we'll fix it. Okay, I'll log in as you and then. Okay, now the next question was from Robin. I'm just curious, when is the last day for the session of students enrolled for Big Data with Hadoop only? And how do we enroll to add Spark at any point? So you can actually go to courses here, see Spark Developer, and go into more details. Okay, and there you can basically click on enroll and enroll there. Okay, using the enroll now, you can enroll. And the last date, actually, I think there are around 4 more classes in this course, including today's. Okay, so in 4 more classes, I think everything with respect to the Hadoop will be covered. Okay, 4 or 5, I think. All right. So don't worry because the Spark course will be in the continuation of this one, and we have planned it in a way that that will be taken care. All right. So we won't be starting the Spark before this course finishes. Okay, there'll be around 4 to 5 more classes in this. All right, so that's how. Great, great. All right, so what we will do in MapReduce is, instead of going too much details into MapReduce, what we will do is we will cover the basics and we'll make you capable of handling it. Okay, as in case you really have to do MapReduce, you should be able to do it. Okay, or at least come back to the slides and take a look at how to execute this and that, and you will be able to discover it by yourself. Okay, we'll keep you till that point. We are not going to go dig deeper into MapReduce. Okay, we'll keep the bandwidth for other technologies and we will keep the focus towards the Spark. All right, so this is basically the paradigm or the idea or the framework of MapReduce, where we break down the logic into 2 parts, map and reduce, instead of having a singular query. Okay, instead of having a single query, we break down it into 2 parts. All right, and we write because inside the code you can write anything. right? While inside the query, you can only write what query you are constrained by here by SQL. Here you are only constrained by the programming language. Programming language is far more flexible and far more easier to control than the SQL. Therefore, MapReduce is generally better. Better as in more customizable, but you need to write the code. And we learn how to write minimal amount of code and get MapReduce working for us. All right, so let's get started. Now, in the similar way, the other example was counting words. Again, this is the analogous to the here we are saying select word, count star from table, group by word. Basically, map defines on what basis we are going to group by. We are saying group by word, and here we're printing word as the key. Similarly, here we are saying group by city, and we're printing city as the key. Correct? So here in the reduce, we are finding the max temperature. In the select, the aggregator is max temperature. Similarly, here we are saying array.sum. This is what we are doing. Here we are saying count star. All right. So basically here we are summing up ones, and here we are just counting the total occurrences. Here also we could do array.length. That could have been good enough. Okay, great, great. So this was what MapReduce looks like. Is it clear to everyone? Sachin's question is, what is the difference between the map and reduces? Okay, okay. Is somebody unmuted? Yeah, Godwin, you have a question. You have unmuted. Godwin Ravi. I think it's by mistake, so I'm going to mute him. Okay. All right. All right, no worries. So here we go. And a question from, there are two questions. One is from Sachin. Can you please explain what is the difference between map and reduce? So you can see that, again, I think this diagram is better to explain that in the map phase, we just select the column on which we want to group the data. We don't ourselves group the data. We let Hadoop to do the grouping. It's just that we inform Hadoop that, hey, my data needs to be grouped on the basis of this. And what needs to be grouped? The values need to be grouped. Okay, so we give key and value. Hadoop takes them and groups them. And then for each of the group, reduce method is called. Okay, so you write these two functions, map and reduce. Map is run nearer to the data, while reduce does not run nearer to the data because reduce gets the data from multiple machines, and hence it's impossible to run reduce nearer to the data. Correct? So this is what happens because when you're grouping things, right? When you're grouping and bringing things, so the data will be brought from all the machines, not from one machine. While on one hand, map runs on multiple machines, correct? Your map function will be run by Hadoop on multiple machines, and whatever the keys are given out by map function, they will be grouped and gathered. They will be gathered and grouped by Hadoop, and after grouping, your reduce function will be called. So your reduce function is like aggregate, while map function is like transformation. Okay. So for aggregation, you generally specify aggregation in the form of reduce function, while the map is the one that does the transformation from raw data into key value pairs. Okay. All right. So that was the idea. Now, a question from Sachin was, uh, a question from Minta was, is count star equal to sum here? That's correct. Count star is equal to the sum here. Okay. Here also we could actually do array.count or array.length. That could have been given us the same results because whether you count once, because this array will be made up of ones, whether you count once or some ones, the some numeric one. Okay, if there is an array of made up of ones, either you sum it up or you count it, it's the same thing. Okay, therefore this count star is equal to that. Question from Binta is how to print out the date of time, correct? So your question is how do I in the output what you want is you want to keep the date, right? Rest of the you want to group the data on the same key, correct? You want to group the data based on the temperature, but you want to keep the data as well. Is that your question, Binta? Okay. Okay. So what you would like to see is that in Bangalore, the max temperature was on 23rd, was 23, and it was on this date. Is that your question? Let's say we want to print the that for Chicago, the max temperature was 21, and it was on this date. While in New York, it was this, right? So the max temperature was on this date, correct? Now, very good question. So let me see if I can explain. So let me clone this page so that, okay, good, good, Hitendra. So here, what we will do is in the value, right? In the value, we will basically give out the date also. Okay, give out the date also. So here, the value will contain the tuples. Okay, the value will contain tuples. Okay, in case of Java, what we do is we convert this into create a composite object, okay, and give that out, right? And here we will basically what we do, it'll be kind of this date will be there in the output. All right, all right. In the similar way, the date will be there in the output. So we'll give out the key values like this. All right. So and so on, right? In everywhere. Now here, what will happen is instead of this way, instead of 23, it will be basically the date. What is the date here? 2014 something, and here it'll be again the date, right? And so on. Similarly, these will be the tuples. Now here, we can't really use this kind of a function. So what we will do, we will say um, the max temperature equals -1, right? This is how we'll do. And we will say for I in values, if I is greater than max temperature, right? Then I is greater than max temperature equals I. So we are saying that go over the list of values. I'll just delete this block. It is obstructing us. Yeah, right now we're just doing it in Python, and then we return the max temperature. Okay, so what we are doing here is we're just expressing our logic in Python just to make the life easier and focus on the logic rather than the code. All right, does it make sense to you? So here what we are going to do is we're going to say for I in values, okay, why I in values. So it'll be a tuple, correct? So we say that temperature is equal to I, and they'll say 1, correct? This is 1. This is 1, not L. Therefore, we'll say temperature. Okay. So we are extracting because here this value is a list of tuple, right? Okay, correct. So here we are not, yeah. So here, okay, it's a good question. So you could also maintain another variable called city, right? City as blank, correct? And we could say here that city equals I and 0, right? That should work out. Okay, a question from Grisma that max should be 0, right? Initially, actually, max should be ideally in the way we say is we call it int inf, right? There's something called negative infinity. Those who are good at Python, they can tell that there is, we basically generally define it something really huge negatively, right? Because any number is going to be. All right. So here, basically, there was a slight twist, and that twist was good because that's what makes us realize the power of MapReduce. Okay. All right. So it's a pseudocode. Remember that it's a pseudocode. We are just writing in it in to describe the overall logic. Okay. So here the temperature, the city will also be there. So sorry, the date will also be there. Okay, the date like this would also be there. All right, so let's see if I could explain again. Let me try to explain again. Now, all right, this looks really yucky. The slide looks really yucky. How can I make it a little cleaner? Okay, let me just try a bit more cleaner. All right, so here we go. Great. All right, I think this is good enough. All right, so here we go. Okay, so the key is the city. This key that you see in the reduce function is the city. The values are basically the tuples array here, and we're basically iterating over the value. Okay, so all we are doing is all we are doing is we are going over these tuples. This is again, each one is going to be a tuple here. So think about this one. This is going to be a tuple containing so this is one tuple. Tuple means a couple of values. And what we are doing is we're iterating over these tuples. Values is an array of tuples. Okay, each tuple, a tuple or tuple, people call it tuple also. So each tuple is basically having the max temperature, sorry, having the temperature and the date. Okay, yeah. So this time is basically, this time is actually misnomer. So we could actually fix this and say date instead of saying time. Okay, so that's all. And here also we could say D for date. If date is not date, this is temperature. Correct. All right. So what we are doing is, what is this values? Values is array of tuples. So we are iterating over these array of tuples and trying to find the max temperature. And as we find the max temperature, we also update the city. So the way we do is we go from left to right, we go from left to right, and we keep on comparing with the max temperature, okay, and keep on updating max temperature, right? That's what we're doing here. And here, I'm sorry, this is not city. Okay, city is basically not no need to give. Okay, you can just give city here maybe. Okay, city. I'm sorry. This I think this logic is wrong. Okay, so if you want to just maintain the date also, then we can keep the date here. Initially, the date will be null, and when it is found, we update the date to we update the date to I think I screwed it. Okay. All right, now it should be okay. I think I was wrong. That's why you had so many questions. Okay, so we are saying iterate over the values, pick the 0th value, which means the first value, 0th value from the tuple. And if this temperature, that will be the temperature. If this temperature is bigger than max, right now, initially we have put a huge max number. Okay, and that's it. So, all right, I think this should be okay. All right, thank you, David. All right. Yeah, now it makes sense to me too. Okay, so we initially have really negative max temperature, and then as we are iterating over the values, we are basically comparing the current temperature with the max temperature. Okay, and yes, thank you again, Grishma. All right, yes, good. All right, a question from Sachin is, do we have full code of MapReduce to execute in the lab? Do we have to return the key value also? Yes, you have to return the key value. I'll show you. I'll show you. As part of the proper full code, similar thing has been not the ML one. We have to take a look at the big data repository. Okay, those who have gone ahead and took a look at it, they can look at the say Python streaming. In the Python streaming, okay, here we have some character frequencies. Okay, and we have Java. Inside Java, we have, let's say, word count. Okay, here's the word count. So this is how the mapper looks like. Don't get scared by the code. So all we are doing is we are given a line. This is a line in our input file, and we are splitting that line by tab or spaces that gives us words. Then we are iterating, we're going over these words, and then for each of the word we are replacing non-alphanumeric with nothing, converting it to lowercase, and then we are printing out key and value. Context.write is what we are printing out. Just that before doing so, we have to do this packaging, unpackaging of the data types. That is something part and parcel of MapReduce. Okay, so focus on the logic which is inside this function, inside this curly bracket till here. Okay, so we extract the value. Value means a line, because this logic of map is going to be called on every line of the input file. Okay, so this is the logic in Java. So this was our mapper. Our reducer looks like this, right? Our reducer looks like this. This is the standard syntax. You have to follow this. The main logic is inside these curly brackets from here to here. Okay, and override means since we are when we are writing a mapper or reducer, they need to follow a certain guidelines. So that's why they must extend the parent class. Those who are interested in understanding Java, they will get it. So here, basically, your reducer class, the logic that you're going to write, it must follow certain kind of contract. Only then Hadoop MapReduce will recognize this as a reducer, and therefore you have to basically do these formalities as such. The main logic is this. Here we are saying this is my sum. We are iterating over the values and then we're summing it up. We're adding those new values from the list into sum, and then we are writing to the context. Okay, this is the real MapReduce one. Now what I wanted to show you is, Okay. Then once we have written the mapper and reducer, there is a third component that you need to write in case of Hadoop MapReduce is you need to stitch the entire thing together. You need to create something called a job. That job will set the mapper class, we'll set the reducer class. Basically, we are creating a job. Okay, we'll specify the output folder. This is how we specify the input folder, file, input folder. Here we have hard coded these names. This is the absolute path of this file that we are going to process. Okay, here this is the folder that it writes to. Okay, and then we say that run the job, wait for the completion. All right, so basically the one good example is available here. Okay, take a look at three files: the mapper, the reducer, the mapper, the reducer, and the driver. A question from Sachin is, what are the interview questions generally asked for MapReduce? Okay, one of the very frequent question is that why do you use MapReduce? Okay. Second, if it's a hands-on question, if it's a hands-on and somebody really want to do MapReduce and things like that, they will basically ask you to write anything that's not word count. Okay. So if that happens, then you can give the example that we have talked about the temperature. Okay. So you can always talk about this part and tell them that this is how it is done. All right. As well as we have more examples in this folder. Take a look at them. There is a character counting, there is a chaining, there is a next word suggestions, then and so on. So if you are really looking for going deep dive into MapReduce, you can do that. The question is any language? Yes, mostly. To be honest, most of the work can be done in Python or Java. Here are some examples of Python. Okay, take a look at that. All right. So, okay. So go over the HDP examples, and this is the folder where you can start with. All right. Great. Great. All right. So I hope this is clear. Further, there are two more ideas that I need to discuss with respect to MapReduce. Other questions that people ask with MapReduce, with respect to MapReduce, is what is the role of mapper? What is the role of reducer? Which one runs near the data? Which one runs away from data? Okay, and so on. A question from Noor, but we don't know how to code this. Okay. Yet you can take a look at that, and okay, and we have already run one example, so I think that will be good enough. All right. If you want to see exact flow of how to build a proper application, so you can take a look at this using Eclipse. I have created something called MapReduce programming. Okay. Okay, so this is basically the Java part that we talked about. You could take a look at the Java part if you are interested. Okay. All right. A question from David is, was the text added to the class? I think the team is working on it. That's what they told me. Let me know from 8. They've added something here. That's okay. Now, this one is not yet added. 9th one is not yet added. Yeah. Yeah. I'll just have to check once more. Okay. All right. Great. So the next concept that is needed is to understand is this was the so far what we've understood is there was one map, there was multiple mappers and one reducer. What if this machine which is running the reducer is really, really busy? What if the reducer machine is really busy? Therefore, you will need multiple reducer machines, correct? On which the reduce function is going to get executed. Those machines will become really, really busy if there are too many keys and so on. So this diagram that we discussed earlier here, right? So if let's say map is happening on multiple machines, there is only one reduce which is doing the sum, count, or whatever, then this will become inefficient, right? So this is where the idea of multiple reducers come into play. Okay, the idea of multiple reducers come into play. So the idea of multiple reducers is that there is raw data. We create input splits out of the raw data, split 0, split 1, split 2, and so on, right? So we create these input splits. What is input splits? Basically some logical version of the raw data. Input splits contain the records. Each input split contain the complete record. At least there is no, while the HDFS block may not contain the block, the complete record. So HDFS block may not contain the complete record. So this translation is done by input format. We'll talk about input format after this. So this is where the uh, basically a bit of transfer of the data happens, a little bit of transfer here and there, because here some boundaries would be this side, some boundaries would be this side. So, okay, we'll talk about that again. So we convert the raw data into some sensible format of data called input split, and then against every record inside input split, our map functions are launched. These map functions give key and values. So sort basically orders those key and values and puts them in two buckets. Okay, here please notice that sort functions after sorting the data, they're putting the data into two buckets. So this, while the sorting is happening on every node, it is basically putting it into two buckets. Okay, so your map functions are giving out key and values, and first the data is split into two buckets, then sorted in that bucket. So that's what happens there. And once all of the functions finish working, they copy the data to a central place. They copy the data to a central place. And okay, sorry. So let me go back. Okay, so raw data is loaded into input formats. Input formats contain the record. Each record is processed by mapper. Mappers give key value pairs. Key value pairs are put into multiple buckets. Key value pairs are put into multiple buckets, and the keys from each bucket is carried to the keys from each bucket carried to one reducer. Okay, so if there are two reducers, two buckets will be created, one designating each reducer. Okay, so there are two, you can see that there are two buckets here, one first bucket and second bucket. Each mapper is putting the data, each mapper node is putting the data into two buckets. Okay, and that's how. So if a particular key, let's say Sandeep is there, if Sandeep goes in on one machine on first bucket, it will also go here if it is found on this machine, it will go in the same bucket, right? If let's say we are doing word count and the first word called Sandeep is put in the bucket, it will go in the first bucket here, 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 so that Sandeep should go only to one reducer node, not to both. Otherwise, the counts of these would be different. Why? Because why? Because the results of these two reducers, so there are two reducers here, the result of two reducers are going to be saved in two different files. Oh, all right. So this is splitting is an interesting exercise. This splitting is done using the hash code. Okay, and using the basically we convert a string into number and we divide that number by number of reducers, and whatever is the remainder, that becomes the bucket number. Okay, so these buckets are nothing but These buckets are nothing but data structures or symbolic buckets here. You can think of them two separate files on these machines, each representing one particular reducer. Okay. Question from Prasant is, so one bucket is for key and one bucket for values? No. So both will have key value. Both will have key value. Okay. Let's say, okay, I think I should just draw it for you. Okay. So, right. Let's say the input is this is a Hadoop class for Hadoop class. Okay. And our mapper is giving out keys. Okay. And the keys are this one is one, one. This is Hadoop. Or let me just put it something better. Is a preposition. Okay, that's smallest. Okay, so here, right? So is one, a one, and preposition one. Correct. This is what Hadoop mapper is giving to give, right? Okay. Now, at the same time, we have that. Okay, let's say there is another mapper. So there are two. This is one input record. This is another input record. This is happening on our first machine. So here, what happens is here we'll get is one, again is one, not one, right? And one, noun one, correct? That's what our mappers will give. Is this clear to everyone so far? Okay. Now these will be split into two buckets. This will be split into two buckets. Okay. This will be split into two buckets. So the buckets are generally prepared based on hash code. Okay, hash code, as in we convert the string into numbers, and then we convert that number into the number which is equal to the reducers. Okay, and how do we do that? Let's say is we convert is into a number. So let's say is 500. Now how would we decide whether to take it on one or second? So the way we do in any huddle, if you have been to say into a gathering where you ask everybody to call 1 2 3 1 2 3 and like that, in the same way. Okay, so that way, that's called hash coding. Let me just go over the hashing, for example. So let's say a number is, okay, so if some let's say a string is converted to 0, then it will be on 0th reducer. Okay, so okay, let me explain again. What is it that we're talking about? We're talking about something called hashing or hash code. Okay, so based on the key, we're going to put it in a bucket. If there are 4 reducers, imagine there are 4 reducers instead of 3. If something is 0, so every string can be represented like a number. Okay, so if that string is converted into 0, then it will go to 0th reducer, then 1, then first reducer. If it is going for, let's say, 4, then again 0th reducer, 5, 0th reducer. So it's a round robin based on the number. Let's say there's a string is converted into this huge number, then it will be divided by 4 and divide by 4, and then it will go to the reducer 5. So basically, key is converted into a number and number is assigned to a particular reducer. Keys can be duplicated, of course. We don't have a control of the keys. Okay, so this is the default strategy on how the bucketing happens. How does one particular word ends up in one particular reducer happens because of this partitioning scheme. Okay, did it make sense? So Okay. Yeah. All right. So let's say you have a bunch of people. Okay. You have a bunch of people, like lots of people. You have their string names, and you want to divide them into the groups. Okay. You want to divide them into 4 groups, right? Such that people with the same name should end up in the same group, right? Let's say you have around 50,000 people, or let's say just say 1,000 people, and you want to divide them into 4 groups such that people with the same name should end up in the same group, right? So one way is we could explicitly say that all the people who are starting from A to F go to the first group, G to I go to the second group, and J to something go to the third group, and so on, right? We could define that. We could explicitly define that. The second way is we convert their names into hash code, okay, into hash code, and which is a number. So string converted into a number, and then that number converted into 0, 1, 2, 3. Okay, and how do we convert a huge number into this? We basically divide by total numbers. Here we'll divide a number by 4, and whatever is the remainder would be the answer. Did it make sense? All right, because this strategy comes very often in almost everything. So I'll just spend a bit more time in this. So we have, say, groups of people, okay? And we have these 4 buckets, okay? These, let's say 4 buckets for now, all right? And the condition is we have to divide them, such that, okay, such that people with same name must be in same bucket. Okay, so what will you do? Okay, one way is we define the range. We define the range saying people with A go here, people with B, people will say A to F go here, G to M go here, M to T go here, and U to Z go here, right? So but the problem with this strategy is that some of the reducers some of the buckets could be overflowed. For example, people here, right? There are lots of people with S. Similarly, there are a lot of people with A. In my whole team at CloudxLab, all of us are either starting with A or S. Okay, so these 2 buckets would be empty while these 2 buckets would be overfilled, right? This is, if you do the range, this is called range-based selection. Okay. Okay. The other way is we convert their names. Okay, convert their names into. Okay, so other way is convert their names into numbers. Okay, and then convert the number into 0 to 4, 0 to 3. Okay, 0 designating this and 1 designated this. Okay, 0, 1, 2, and 3. Correct. So instead of range-based division, we can do it in a faster way, this way, and this way the load will be better balanced. Okay, now how will we convert a name into a number? Name into a number we can do in many ways. We can sum up their alphabets, and a huge number could come out. And that also means that there could be 2 different names which could have the same number, but that's okay for us. As long as same name is resulting in same number, we are completely okay with the different name resulting in the same number. Correct? The objective is that people with the same name should end up in the same bucket. Okay. So let's say there is Sandeep. Okay. And we compute the hash code of Sandeep. Let me just show you. There's a quick way of computing hash code. Okay. Quick way. I have Scala here. And using Scala's prompt, I can compute the hash code. This is the hash code that is used by Hadoop. Okay, so you can see this is a huge number. So Sandeep is converted into this huge number. Now we need to convert this number into something between 0 to 4. So what we'll do is we'll divide it by 4. Resultant is always going to be lesser than 4. Okay, is it clear to everybody? So if we have say Prashant here, so we could say Prashant. Now this one is -1. Okay, so we could again say mod here. Okay, we could again say import math. Okay, or we could just say, all right. So basically that's separately different thing. All right. And here, let's say somebody's name is Sachin, for example. Okay, the hash code is again for Sachin also it's 0. Okay, and if we put Sachin Sikri, then it is going to be, wow. For you, all the time you're ending up in the 0th. All right, let me just delete to last word. Yeah, this one is different. Okay, a question is why is the remainder negative? The remainder was negative in case of Prashant, right? Why is that? Because Prashant.hashcode is giving a negative number, right? That's the reason. All right. A question from Sachin is, what do we mean by hash code? Hash code means it converts the string into number, not always unique value. Unique as in Prashant's hash code will always be this, no matter how many times we are going to do this. No matter how many times we're going to do this, we are going to get the same hash code. Okay. Now the problem is that like for example for Sachin and Sandeep, the hash code was I think okay. The hash code could be same for two different strings. This hash code that you see here, it could be same. Okay. So we create the hash code and pass the hash code to the reducer and then change it back to the original value. We don't do anything of this. The Hadoop is doing it for us. Okay. Hadoop is doing it for us. This is what it is doing. Okay. Though we can define something called partitioner, and in that partitioner logic, we could define our way of sharding or our way of partitioning. Okay, this is a standard partitioning technique that we are talking about. This is hash code based. This is used in many ways. Okay, this is something that we are not doing here. Okay. All right, so we don't do any of this. Hadoop is doing all of this for us. Basically, the key values, we just give out the key values. Hadoop basically splits them into buckets and put them in these buckets. Please note that at the end of, I'll just go back here. Okay, so this is how the partitioning is happening. Is everybody clear about partitioning? So some of the keys are going to go to one reducer, some of the keys are going to go to another reducer, and for that we have buckets here. Each bucket would contain the sorted keys, and rest of the flow of merging them and executing reduce logic would remain as such. Okay? If there were 4 reducers here, there were 1, 2, 3, 4 reducers here, there would be 4 such buckets. Okay, each one to be carried to separate reducer. Okay, so the splitting happens on the mapper node itself. Okay, this is done by Hadoop. Hadoop gives us a way to customize the partitioning strategy. The default partitioning strategy is based on the hash code and is kind of round robin. And we can customize it to whatever we want. All right. So this is what is going to happen. These keys are going to be merged, and then the reduce function is going to be executed. Then part 0 and part 1 are going to be saved in the HDFS. These part 0 and part 1 are going to be saved in the HDFS. All right. A question from Subbu. All the data in Hadoop is stored in hash code? Not really. The hash code is only used for partitioning. Then this hash code is actually discarded. Okay. This strategy that we talked about is only used for division of work. Because we can't really do random splitting, because what will happen is, imagine that Sandeep went to first bucket here and Sandeep went to second bucket here. So what will happen is here the counting will go wrong. Okay. It is done to reduce the load on one of the single reducer. That's right. So instead of one reducer, we are using two reducers. Now, how does the separation of keys happen? That is decided by partitioner here. Partitioner basically partitions the key and value output of the mappers, and then we put that into these buckets. Okay. A question is, where is the merging of the two reducer happening? Answer is nowhere. Okay. The result of the reducer is not being merged. Both are creating their own files. That's why what would happen is, this is a very interesting question, that what will happen is, if you have two reducer in case of word count, some of the words will go to the first file and some of the words will go to the second file. Eventually, this part 0 and part 1 both of them have the word counts, but if you wanted, let's say, the data to be sorted and a single file, then we can't achieve this. Okay, here. Therefore, what we do is we define our own partitioner such that the partitioning happens such that range partitioning happens. Okay, the way I was talking about. So imagine that we have only two partitioners, partitioner 1, partitioner 2. Okay, and we are saying there are keys like the mapper is generating the keys like apple, banana, apricot, okay, and say carrots. Okay, so here what will happen is, even though the data of both of them will be sorted, okay, let me just put it this way. Okay, so this is our mapper, and okay, so let's say this data is getting split into two parts. The resultant will have apple and banana and apricot and carrots, right? And their counts. Okay, so there'll be two separate files in the end. So if you want this to be explicitly done, then we define our own custom partitioner such that we define that all the values, say lesser than equal to b, go to the first reducer. Okay, so then banana will be here, and the carrots will be on this. So we can play that, we can make sure what goes in two files, okay, by the way of defining our own partitioner. Okay, so this partitioner we can control. All right. So nobody merges these partitions. Okay, so we will talk about it again. So reducers write to the disk parallelly, write to the HDFS parallelly, and we can't really merge them. Instead, we concatenate the two files or use the result of the two files into some other file, into other project. Okay, so just we need to ensure that what goes into each of the file, we can control that by defining our own partitioner. All right. So a question is partitioning done manually? No, we basically write a piece of code which given the string, given the key, needs to give out a number designating which reducer this key should go to. Okay. A question from Rajan. You mentioned that after mapping the two keys with the same value will end up in the same bucket. You mentioned that uh, after mapping the two keys with the same value will end up, as in, if two keys are equal, they will end up in the same bucket across the node. Okay. All right. All right. So yeah, let me understand your question. You mentioned that mapping the two keys with the same value will end up in the same bucket across the nodes. Yes. Okay. Let's say there is Sandeep here. Sandeep is given by, let's say Rajan is here. Rajan goes to say first bucket. Let me just check what will happen to Rajan in case this. So Rajan dot hash code percentage say 2, right? Okay. So Rajan would go to the 0th one. Okay. That means the 0th is this, 1 is this. Okay. So percentage means we find the remainder after dividing something. Remainder would always be lesser than the total count, correct? So therefore, if we are dividing by 2, the answer is going to be either 0 or 1. Okay. If you are dividing by 3, the answer would be 0, 1, 2. Okay. Similarly, when we divided the hash code by 2, we'll get 0 or 1. So in case of Rajan, we got 0. So Rajan, wherever is the key, Rajan comes here, it will go in the same bucket, 0th bucket, here, here, here. And when these buckets are gathered on the reducer node, they will be merged together. And here the grouping will happen. Here sorting is happening, merging is happening here, and the grouping is happening here. And after grouping, our reduce function is being called. So merging and grouping is happening here, and then the reduce is being called on every group. Did I answer your question, Rajan? So no matter on which machine you print the key is produced. These boxes will be equal to the number of reducers. Okay, if there are 3 reducers, there'll be three boxes here. So question from Sachin is bucket is also a piece of code. These are basically bucket could be an array, bucket could be a big data structure in which the keys are kept temporarily. That's what it is signifying. Bucket could be a file. Okay, this bucket where the output is being saved here. This bucket is going to be mostly like a local file. Question from Hitendra is merging is simply concatenating of different partitions? Yes. Merging is simply concatenating of different partitions. Merging is that same merge that we talked about. Each of these partitions are going to be sorted by each of the machines. So after map has produced these partitions, right? Then these partitions are going to be sorted. And after sorting, the merging is going to happen. So after partitioning, the sorting is happening and these files are being merged here. Merging the same way, the way we showed you the example of merging the people with sorted heights, that way the merging will happen. Okay. All right. All right. So a question is, what is the relationship between sort, partition, and shuffle? So here, first partitioning is happening. Some of the keys are going this side, some keys are going this side. These keys are going to get sorted here. These keys are going to get sorted here. So partitioning followed by sorting, and then merging is happening here. So this is also called shuffling step, where the data from multiple machine goes to one place and get merged. That's also called shuffling and merging step. Okay. All right. A question from Node. There is a problem statement where we want to create a mean of values stored in HDFS. And if we don't merge the values from the two reduce, then how can we achieve this? Good question. Good question. So mean of some key, right? So mean would be a question from Noor is that let's say what we want to do is we want to find out the mean of the values. And for mean, we need values or all the values, correct? And some of the values could be going in partition one and partition two, right? That's why what we do in such cases, is that we create the key such that all the values of which we want to create mean, the key is same for all of them. Okay, so that they are all grouped together and they come to the same reduce function. All right, that's how we generally achieve it. All right. All right. So yeah, a question from Aniket is, so is every MapReduce program is about sorting and merging? I have Hive queries which run as MapReduce. Sometimes I do plain select or sometimes insert. It is underneath. Yes. So question is that can all of this be, can this whole thing be used in simulating any SQL query? Yes, the answer is yes. And that's what Hive does. Let's say when you do only select star from something, it will not have any reduce phase. No sorting will happen. Only the mapper code will run the select whatever you're doing and will directly save in the disk. There'll be no sorting, no partitioning, no merging. When we are saying group by some key, that means the mapper will give out the key and the value, and then the sorting will happen, then the data will be carried here, and so on. Okay, so basically the whole mechanics happens based on query. So good news is that we don't generally have to write mapper or reducer or control any of this. Most of it is done by the third party or the systems above it. Okay, if you want to interact and control MapReduce by ourselves, we can also do that. But the tools like Hive let us do it. Let us do that. Okay. Now, yeah, I would love to answer your question again. Please feel free to copy paste again because there are just too many questions. So from here, you could just copy paste which if your question is not answered. I'd love to answer again. because multiple persons have the same question, so I had tried to answer. So feel free to ask question again if it is not clear. Just copy paste the question. So we only write the mapper and reducer, and while executing the job, we can tell Hadoop that we have number of reducers as 2, then this will happen. So we are providing what all input we are providing. We are providing, let me just mark the inputs here, and then we'll talk about which all things we can control. So here, this is the input file. Okay, this is first input, the input file that we'll provide. Okay, this is one input. Then output directory. Here we are going to provide output directory. Okay, output directory. What else do we have? Okay. Okay. Now, this is the another piece of code. This is the logic that we will write. This is the logic that we'll write, the code, right? Then this is another piece of code. We are using Hive. All of this is generated by itself. Now, this is the piece of code that we specify. So 1, 2, 3, 4. And then the next output that we give is number of reducers. Okay, number of reducers. Okay, number of mappers is generally decided by how many blocks does your data has. That is generally decided, that generally decides how many mappers you're going to have. Okay, we don't write the we don't define how many mappers we are going to use. Only in the cases where we are not processing input file and we want to run mapper, like for example reading the data from a database. Okay, let's say our mapper is just reading the data from database, and in that case we can explicitly define how many mappers are going to be. Okay, so 1, 2, 3, 4, 5. These are the 5 input parameters that we pass. The input or our input goes here. The number of mappers is number of HDFS blocks. Okay, for the input data. Input data could be an input file or it could be an input folder. If it is an input folder, all the HDFS blocks of all the files will be counted as input. Okay, now sometimes we may want to control the partitioning here, on what basis data is getting partitioned. Okay, on what basis the data is getting partitioned here. Okay, that also we want to sometimes specifically want that, hey, my data should be such that first reducer contains this, second reducer contains this. Okay, that we control the partitioning. Okay, third part that we can control is here itself there is something called combiner. Okay, so we can define our combiner here. Okay, sometimes because reduce is going to be overly overloaded, right? If there are so many keys here, that so if you want to get some of the reduces work done here on every node, on everywhere, we could define something. We could just pass the same reducer as combiner and we'll be done. Okay, now this is what these are the various inputs to the MapReduce program. And also here the input file format. This translation, how will this happen? That also you can control by the way of providing the input file format. Okay, by default it is considered text input format, text input format. Basically, in case of text input format, your mapper function will be executed per line of the input text. Okay, is it clear? Clear to all of you? 1, 2, 3, 4, 5, 6, 7, 8, and number of mappers. That's also optional. Okay, so these many inputs. All right. Then furthermore, we can customize like the record format by ourselves. We can also define our own input. We can create our own classes here. We can also define many other things here, like sorting strategies and so on. Okay. Now let me answer your questions. So question from Sachin is, do you mean key with the same value should go in the same bucket? Same key means same content, right? Mapper will give key and value. Okay, I don't want to use value because you will confuse that value with the output of the mapper. So mapper will give key and value. So if same key, like Sachin comes here, it should go into the same bucket if Sachin comes here. Otherwise, what will happen is Sachin would end up at two places. So if the Sachin key comes one place, at different places, they should go to the same bucket. Otherwise, grouping will not happen correctly. Okay, for grouping to happen correctly, the group there should be only one group for the same key. All right. A question from Grishma is, I think practical example, it's easy to understand. The practical example you can think of is with respect to the temperature, max temperature kind of thing. And let's say we want to do the max temperature of the city computation on these many machines, and there are just too many cities and too many values. So instead of one machine getting overloaded, we would like to have two machines. Imagine that the temperature of one city went to two different machines. Okay, then the outcome will be that Chicago is here as well, Chicago is here as well. So Chicago must go to the same bucket. Okay. All right. So you can take a look at the coding in the GitHub. If you want, you can keep a separate session for the coding because I had not planned that one. Okay. Now, okay. A question from where is the driver code? So basically, the which driver are we talking about? The driver code that we have given in the GitHub. Okay. So yeah. Okay. Next question is, where is the driver code? Driver code is basically the way of submitting the job to MapReduce framework so that it can pick up which part is mapper, which part is reducer from the driver code. So driver code is only for submitting the job. Okay. Rest of it, basically, by the way of driver code, what we specify is where is our input file, where is our output directory, what is going to be the code in mapper, what is going to be code in reducer. So driver is kind of a bundles everything into a single place. Okay, driver is kind of main method of the whole thing. Okay, all right. So that's the driver code here. Driver, basically when you say Hadoop submit, the driver code that I showed you basically bundles everything together, right? Just like the main method of anything. Okay. Now question from Sachin, do you mean key with the same value? No. Okay. It should be the key with the same content must end up at the same place. If two keys are equal, they must be in the same reducer node. Okay. A question from Hiten, how to determine number of reducers? Generally, it's mostly a hit and trial. Okay, it's mostly a hit and trial. If it's taking too much time to do reduce on the nodes, it's taking too much time to do reduce, try increasing the reducers. If the suffering time starts increasing, because if you run any MapReduce job, it prints you all the statistics. Okay, That time you can figure that out. We'll talk about the number of reducers. Question from Robin. Before input file to HDFS block, how is number of blocks automatically determined for each input file? So basically, for each input file, when we hand it over, MapReduce framework basically it tells Yarn. Yarn talks to the name node. Name node tells information to the Yarn that hey, there are these many HDFS blocks, and hence there are, and based on that, it creates the input split. So Yarn inquires, or you can say Hadoop MapReduce inquires the Yarn, and sorry, Hadoop MapReduce talks to name node, or Yarn talks to the name node and finds out, where how many blocks are there for every file. Okay, question from Sachin. Can you explain again what is the function of partitioner and combiner? Partitioner basically splits the data into two buckets. Okay, let's say you want to customize, you don't like the default one. What the default one will do is some of the keys will go here randomly, some of the keys will go here, right? You want to explicitly say that all the keys, all the people's name starting from A to M should go in this bucket, while N to Z should go in this bucket. If you this reducer, then you can customize the partitioner. Partitioner's role is decide to which machine should a key go. Okay, that's what is decided by the partitioner. All right. While the combiner basically does the role of reducer just after here, so that the role, some of the reducer mechanism should happen itself here itself. Okay, so that's what is the combiner. The items that I've just drawn, these are the various inputs you provide to Hadoop MapReduce. Okay. All right. All right. Question from David. How is the final result achieved when the data is on two different HDFS files? Okay, it's actually files. So yeah, question is how is the final result happens when the file is on two different the output is in two different files, correct? So yes, so it's an important question, and let me answer this. Let's say there are two files, part 0 and part 1. Question is, how do I concatenate? But before that, I must ask you is, why do you want to concatenate? This input file, when we are saying, this input file could be a folder. This input file could be a directory. Okay, the input file could be a directory. So when we have this output directory here in which there are two files, we can feed to our rest of the processes the whole folder instead of a single file. Okay, so keep that in mind, that we can generally use that. We can generally feed the data from the two files to another programs. Okay, now if you want to have explicitly one file, one thing we can do is either have one reducer, or we can use something called Hadoop FS cat. Okay, there is a file, there is a command called Hadoop FS cat that will concatenate the file and give you the result. But this is just too expensive. If you have a few terabytes of files, then the can concatenate will basically give you just too many output, and you can save it to some local file. Okay, and Hadoop FS command also gives you a way to concatenate. Okay, now question is, let's say it is important for us that we concatenate the two files, and it's important to get the final result, for get the concatenated result. Now, if let's say your data got split into two parts, correct? Part 1 and part 2. You can't really concatenate it. I'll show you right away. You remember our last example, all of you? Last example was in the case of we did SSH and okay, right? So we were last time we were doing the from the project we were doing that. So I'm going to do is I'm going to specify the number of reducers and run that again. Okay. So where was the my project? We had checked it out in big data folder, correct? In the big data folder, we had HDFS examples, right? Inside that, there was Java, and this is where our code is. So I'm going to use vi src com CloudxLab, or we can use Jupyter to edit this file. Uh, okay, I'll also use Jupyter. That will make our life easier. So I'm opening Jupyter and we'll edit this file from Jupyter. Okay, I'm going to show you how does it look like with multiple reducers. Okay. So if you have already checked out the code, you can also try the same thing. Okay. So where is my code? My code is in big data. Okay. You can go to my lab, click on Jupyter, and you'll get here. So I'm going to HDFS HTTP examples and clicking on Java and SRC. Here. Okay. So we have, let's say, driver, step driver. Can I edit it? Oh, there is. Okay. I'm going to increase the number of reducers. So here, I'm just specifying number of reduced tasks. So job has a parameter to set the number of reducers. Okay. And I say save. That's it. I've saved the results. Then here, again, I'm saying ent jar. It is compiling. Also, I'll delete my output folder. What was my output folder? My output folder was this. So I'm going to delete it. So I'm going to say Hadoop, or I can just say move this to this one. Okay. So now let me just run this program, and you remember the command that we used to run that time. So if you go to Hadoop, CloudxLab, big data here. Okay. So this is what we have done, and then we are going to execute it again. All right. Okay. All right. And where will the results appear? Results will appear in hue. Hue was on D. Okay. So these are the statistics which it has printed. You can see number of reduced tasks were 2. Correct. So the MapReduce can be very huge and overwhelming depending on the problem statement. Correct. Mostly the Java code, Java programs are like that. So our code is in the Jupyter, which means local disk, and our data or the output, input as well as output, is in the HDFS. Okay, so I'm going to show you two parts. So here there were 2 folders. This one we created last time, right? And this was created today, and this was created last time. So there you can see that there was only one reducer, therefore there was only one file. By default, the number of reducers are one. Okay, and here today we set two, correct? Now let's take a look at these files. Okay, part 0. So part 0 contains, let's say, these records. Okay, I'm going to put it in a text file, but this is our part 0. Okay, or let me just create separate notebooks, notepads. This is our part 0. Okay, and this is our part 1. Okay, I'm going to take it and just put some of it here. So this is part 0, and this is part 1. Yes. A question from Rajan: when you set number of reducers, that means there are two partitions in the output data. Yeah, two parts of the data is created. Each reducer, this is what's happening here in this diagram, part 0 and part 1. Okay. All right. So no. So this is where that's happening. So Rajan, so you can unmute yourself and rephrase the question if you want. So when you set the number of reducers to 2, we set 2 here. So this whole mechanism happened. Yeah.
So I think my question is like on the sort you created two buckets, right? And,
Right.
And when you increase the reducer, then you automatically get
More buckets. Yeah.
buckets, right? Is that correlation there automatically?
Right. So if there are 3 buckets here, there will be 3. Like if you go back here, the individual files that was there on each machine, it was only 1 bucket, right? Here there was only 1. If there was more reducers, like 10 reducers, there'll be 10 buckets on each machine. These are nothing but local files that are being produced on each machine, and these local files will be merged at a central place.
Okay.
Okay.
So but actually, like somehow on the mapper side, the number of buckets will increase as if I say more, add more and more reducer to it.
Correct.
Okay.
So total number of output buckets will keep on increasing, and therefore the framework overhead will keep on increasing. Okay. So question is that where is the code? You could go to Jupyter. Okay, let me show you how can you go to Jupyter. You go to CloudxLab/mylab. Okay. And then click on Jupyter. So you'll get Jupyter like this after starting the file, the server. Then you could go to big data/examples. If you already checked out this big data project, which is here, you can check out from here. Okay, you can do git checkout and it will appear in your home directory inside it. Okay, and then we said here, we clicked on edit. So on step driver. Okay, so that's how it is inside this folder. Okay, inside this folder, I'll just copy paste. Okay, I just copy pasted this full location: big data, HDP examples, Java, SRC, COM, CloudxLab Hadoop. So this is the step driver. So here all the options we have commented out. This is the only part that we have just set. Okay, now let me just close this. So this is where we are saving it, and this is where we got it from, and this is the output. While this is where we ran it. Okay, we did ant jar just like the way we did earlier, and then we ran it. Okay, so once we ran it, we got this folder. It has two files, part 0 and part 1, while earlier we had only one file. Let me just open the old file. Okay, this is how the old file looks like. Okay, now let me just show you parallelly in three screens. So this was single file. Okay, this is part 0, part 1 that we did today. So you can see that this particular key that was in a single file, it went to the second partitioner, the empty one. I think it's empty file, empty key. This one went to again second reducer, while this one went to the first reducer. Okay, so you can see that. Is it clear to all of you? Question from David is, how do you get part 0 and part 1 into single file when you use two reducer? The answer is that you can't. Okay. Now question is that if we try to concatenate, say, these two files, let's say these are part 0, part 1, if we concatenate this, then the result is going to be bad, right? The result is going to be bad because even though both of these partitions independently are sorted, but if you concatenate part 0 and part 1, the resultant is not going to be sorted, correct? Correct. So now question is, from my opinion, if it doesn't matter to me in what order is my word count, then this folder is my final result. Okay, this folder containing part 0 and part 1 is my final result. While in case what we are looking for a singular file containing the data in order, what we want is our word count should be in order. Then what we have to do is we have to define our own partitioner such that the keys do not go like this. Keys should go with non-overlapping ranges. Non-overlapping ranges as in here it should have gone all the things starting from 0 to j, and here it should go everything beyond j. Okay, so that way we could create our partitioner, and that way these partitions part 0 and part 1 we'll be able to concatenate and get the result. Okay, so we have Hadoop fscat command. Okay, we can use that. Okay, you could see. Okay, let me just try. Okay, so fetches all the files that match a pattern and display their content on stdout. So we could say is Hadoop fscat, and we could say jr mout. What was that? Java mr out, right? Java mr out, right? And then save it to a file. All right.
Sandeep, I have a question. Can you just show me like where exactly you made the changes for number of reducers?
Okay, so I went, first of all, I cloned, have you cloned the directory from GitHub?
Yes, I think I have the directory present on my
Okay.
Jupyter console.
Can you share the screen? I think that'll
Okay,
be
okay.
everyone. Okay. So
Okay, let me start.
given the code, you should be able to, Okay, can you give the instructions of running exactly the way I'm doing, Sachin? So all you need to do is follow these instructions. That is good enough for you. Okay, git clone, then you do this, then execute this. Okay,
Sandeep, you're able to see my screen?
just give me a second. I
Okay.
This one is on the screen. Okay, just a second. Let me move
Okay.
the chat to another window. Okay, yeah, I can see the screen. So,
So here is what I have on the Jupyter.
okay, good. You're good. So go ahead. Yeah, click on edit. Okay. So now go down, change the number of reducer. You can see there is, I have already put a comment. Double slashes in Java means comment. So for line number 43, uncomment that line.
Okay, okay. I just commented out.
Okay. Yeah. So just save it and go back to the terminal. Okay. Now, so we moved our yesterday previous sessions folder to Java MR out 1. Okay,
Okay.
because otherwise Java, because Hadoop MapReduce wants you to provide an output directory which is not exist. Okay,
Okay.
otherwise it'll give an error. All right, go ahead, please. Okay, so I think this will work, and then you can go into your home directory and take a look at Java MR out folder that would be created. This has been renamed now, right? It's processing right now. It has created this temporary. There's a temporary folder there. This is where both part 0, part 1 will come as soon as the process
Okay.
finishes.
Okay.
Okay, now go back and you'll see that. Refresh.
Just
Okay. Refresh it. Why there is only one part? Ouch. Why?
image.
Okay. Did we save this file?
Yeah, I saved it.
Okay. Okay. Go ahead again. Let's just do it. Oh, we did not build it actually. We were supposed to build it. Okay. So
And char.
and char, yes. But and before executing Hadoop, we have to delete Java MR out.
Okay.
We have to say Hadoop FS.
So is it like default that in every location this folder will be created Java MR out?
Yeah.
Okay. I mean it's inbuilt in the Hadoop. I mean the
No.
MapR.
We have hard coded there, no?
Okay. Okay.
Java MR out. We have hard coded
Okay.
driver. If you want to create another folder, change the code,
I got it.
or
Okay.
we can also take it from the argument also.
Okay, I
Whatever
got it.
argument we pass to a stub driver will be taken there.
Okay.
So great.
Okay, Sandeep, I think I should be good now.
Oh, you have to. Oh, this is failing this time again. You have to execute probably again.
Could not find local directory.
No worries. So I think all you need to do is just do it again. Okay. Delete the previous folder again, Java MR out again. And yes. Just delete it. Say, yeah, RM. Okay. RMR. You have to say RMR.
Yes, for directory.
Okay. Yeah, it's done. Now try executing again.
It is showing me RM minus R.
It's done. It's done. It's just warning. try executing Hadoop jar command. Yeah, that's it.
It is showing could not find any valid local error.
Mhm. Just try once or twice. I think that it'll work. Do the same. I think it happened with me the other day also. But after I executed a couple of times, we need to yet figure out why it happens. It is okay. Okay. I think yeah, I think it should work this time.
Okay.
Sandeep, I am getting some fatal error.
Okay. No, the fatal error is because you had already checked out. You just have to go into that big data folder and say git pull. Okay. You don't need to clone again because you have already cloned it.
Okay.
Okay. Git clone means you are bringing from GitHub to your local folder. And since you did it already, therefore that's happening. Okay. So you have to follow everything after the first line, the git line. You have to go into that folder using cd command and then and
I disconnected. So
Mhm.
which folder I need to go?
You just go to that the command that I copy pasted. Na? You can see my screen.
Yeah.
Mm.
CD picket.
It was there. Na? And when you go to Hadoop examples in Java, it shows on the GitHub also that what is the commands to be executed. And I also copy pasted that. So you say cd big data slash HDP example slash Java. Go into that directory, then do and jar. And jar means compilation. And then Hadoop jar means executing the command. The command. Okay.
And then after that, what we need to do?
Then you have to go to the yeah. So all right. Just a
It came.
second. Okay, okay. So then whatever we did just now, whatever Grishma was saying, then those parts that we wanted to show you. Okay.
Hadoop
Uh,
jar, build jar. And
just a second. Yeah. So yeah. So what is it? What is you? Do you want to try what we just did, or you?
yes,
Okay.
I want to try.
Okay. Okay. You can show me a screen. I can help you out then.
Yeah.
Okay. It could help others as well. Okay. So
Yeah.
Abhintav, I'll answer your question shortly. Just I'll handle this. So it says that the output directory already exists, right? So we have to delete
Yeah.
that output directory.
So where we need to go?
Which Hadoop FS. Instead of CD, just first delete the output directory. You are in the right location. Because what happens is every time it creates the output directory, okay, even if the command is not successful, even then it does. So I'm going to give you this command with which you can rename your where was that command? uh, Hadoop fs-move Hadoop, or you can just go to Hue. Can you open Hue? All right, let's just start from the beginning. Okay, so can you open GitHub repository folder there, the fifth tab in your browser?
Yeah.
Yeah. So okay, this is the Jupyter notebook you have, right?
Yeah.
Okay. Now you also open the Hue. Okay. Click on My Lab. Click on My Lab, the third folder, third
Yeah.
tab. Click on Hue.
Yeah.
Click on File Browser. Okay. So you see Java MRout is already there. This is from yesterday's or so. You can rename it. You can rename this folder. Actions, click on Actions. Go back up. I think it is there. Yeah. Select the folder, click on Actions, rename, put one here. Okay. So this was the older folder. That means now we have changed, renamed it. Now okay. So here, have you changed that content? Did you change go to now, go to now Jupyter, go to Jupyter.
Yeah.
Right. So go to SRC, HDP example SRC. Okay. Here go to COM, CloudxLab. Okay. Click on word count. Right. And then click on the stub driver. Okay. Not this. Close this. Yeah. You have to select the checkbox.
Yeah.
Step driver, not reducer, step driver. Okay, good. Now click on edit. All right, all we are trying to do is we want to edit the file. To edit the local file, we use the Jupyter. To edit or see the files in HDFS, we use Hue. And to execute the Hadoop job, we go to the terminal. All right, so all we are trying to do is editing the step driver to change the number of reducers. And how do we change the number of reducers? Come down. I have already written the code. It's just that we have not changed. We have kept it commenting. On the line number 43,
Okay.
you can uncomment the file, uncomment this line.
Yeah.
Okay. Yeah. So here the indentation is wrong. So you can fix the indentation by pressing one tab again. Okay. Yeah, this is good. So although in case of Java, the indentation doesn't matter, but as a matter of good coding, you should keep this. Now go to File and save it. Click on File and save it. Good. Now it is saved. Now we need to recompile the code. Okay.
Yeah.
On the console, do pwd. Okay, this is where we are. We are inside the checked out folder called Big Data, the one which you have checked out from GitHub. Then we are inside HDP examples, inside Java. And here we are saying ent space jar.
Yeah.
Okay.
So
this
and
is,
will compile all the codes.
yes, ent will compile the code, but it will do the incremental. It only compiles the files which are modified.
Okay.
You can see that compiling only one source file. Okay. And now it has smartly compiled only the parts and updated the jar. Now you can execute the Hadoop jar command. Okay. Yeah, this is the one that we used earlier. So where will the output come? In Hue or in Jupyter?
In Hue.
Correct. So let's just wait here. All right, so looks like it has finished successfully. Now go back to Hue and take a look at it. Refresh it. Control R should do. Yeah, there it is. Now you can see there are two files.
Yeah.
All right.
Yeah,
Great.
one question. If we want to separately each by each code we want to go, it is not a good practice.
Each by code as in?
If we want to compile like Java C and then the code.
That's also good practice, but in reality, in the industry, right? People don't use Java C because the problem is that you will have to compile three files, right?
Yeah.
Step driver, step mapper, and all of the dependencies. You have to specify all the things in the libs, right? We have like 15 libraries, so it'll become a big headache. Generally, what people use is people use the either Eclipse to compile. So if you want to use Eclipse, you follow that online tutorial that will help you, the
Yeah.
one that we have created. Otherwise, AntJar is the one people use in the production. AntJar or Maven jar. Maven is the upgraded version or the similar tool, which is new advanced. Maven, M-A-V-E-N, which is also being used in place of Ant. Okay.
So jar
Mhm.
is this jar is given by JDK or by Oracle.
This which one?
Jar file.
This jar file. Jar is nothing but zipping all the class files.
Okay.
Okay. So Java C basically compiles all the code into .class files. Then jar basically bundles them like zip file bundles all the things. So if you want to check, you can use a file command, file command, to find out what is there inside a file. You will find that it is nothing but zip content.
Okay.
Okay. All right.
Yeah.
Good.
Thanks.
Okay. I hope this was useful for others as well. All right. A question from Bintao is that if we can't write up MapReducer in driver, we will not be able to create jar file, and then we cannot run the word count. Not really. I'll show you today how to do it in using the Python. Okay. I'll just show it using any program. That's what is the next topic. Okay. So there's the sole idea. Okay. Who is unmuted? Somebody is unmuted. Okay. Now this is good. Okay. All right. The important part is, let me just create the steps if I can do. All right. Let me just try to see if I can do the steps. So basically, the first step is clone this repository, go into this folder. Okay. Then execute this. Or we can also optionally, okay, optionally edit the files. Okay. Optionally edit the files using Jupyter. Okay, how to do that? I'll just write it here. First of all, what we have to do is from my lab, open Jupyter. Okay, then go to this folder, src com CloudxLab, right? That's the one which we have. Okay, go to this folder. Okay, and then word count. Okay, to edit, to change the uh, word count example to use two reducers, change uncomment, line number 30, line number 43, right? In word count slash stub driver. Okay. Okay. And then again, you basically go here to the ant jar and then run this. Okay. This will, okay. And this will create Java mrout. Okay. This will create Java mrout folder and Java mrout folder. You can open Hue from my lab MyLab and click on File, Browser to check the output. Okay, so this is what I wanted to write. All right, so I'll just update it here. I think that'll help. Can I edit it here? Okay, so I'm just updating it for all. I hope this is useful to everyone. It was line 43, right? Can somebody help? Line 43, correct. Okay, there are typos. There was a question regarding Spark. Yes, Spark eliminates. Now, by this time, you all must have realized that writing a MapReduce code is a pain, correct? And therefore, there are alternatives to it. One of them is using the, I'll tell you the alternatives. Okay, so alternatives were using Pig. The first alternative, the one that I've used always, is Hadoop Streaming. That's like most simplest way of using it. Then there was Pig, then there was Hive, and now there is Spark. Okay, so for most of the computing, people are preferring Spark over Hadoop because of many reasons. Performance plus the time it takes to write something. Okay, so all right, now coming back to questions. So basically, Spark kind of has eliminated the need of MapReduce. It's just for the backward compatibility reasons, so that you have the idea of what's going on. We are discussing MapReduce. Okay. A question from Sachin: what is the order in Java code run in all Java files? So here, take a look at this command. Here, this command is saying Hadoop jar. This is the folder this is the zip file that contains all of our code. And we are telling that, hey, you run this particular class. And what is this class? This class is essentially the class that exists inside com folder, inside CloudxLab folder, inside word count, which is step driver. So this is the file that is going to be used as an entry point. So this is the driver that is what we are specifying to Hadoop command, and the driver is the one that hands over, that creates the job and tells Hadoop to create a job for us. Okay, so driver is the entry point. Yes, driver is the main method. Driver contains the main method. All right. All right, I hope you can use any number of reduces, up to you. You can try creating 4 reducers and it'll be good, right? Question is, where is the partitioning logic right now? If you take a look at here, there's no partitioning as such, right? There's no partitioning logic. Here, I'll show you. So now that's the second thing I would love to show you, okay? Because that's something that you will have questions about, okay? So I've edited the file again. I've just closed the old one, okay? This is my file, right? This is the entry point, and I have already written a lot of code which you can just comment out and things like that. Right now, there is no partitioning logic, right? Okay, but if you do not specify the partitioning logic, what happens is it uses the default partitioning class. Okay, partitioning puts various things in various buckets. Let's say what we want is we want our own custom partitioner. So let me show you a quick example of step partitioner. Don't worry if you don't get it. It is not too hard. So here all we are telling is if anything lesser than k then go to the first partitioner. If anything greater than, other than that, go to the second partitioner. That's what we are doing in this. Okay. All right. So I'm going to just show you. So don't worry about Binta, don't worry about that part, the language proficiency part. I'm going to show you that part. Okay. Here, this is just the optional part we're doing. So it can be written in other languages as well. Okay. So here we have the partitioner which we have defined. So don't worry about writing this code. Here, this code says that in case the first character of each key is lesser than k, send it to the reducer 0. Otherwise, send it to the reducer 1. Okay. So this time we want a different output. Okay. Now, what we want to do is our files, right? The one that we created just now, they were kind of, round robin manner. This went here, and so on. Let's say we want to create a logic such that lesser than k goes into one file and greater than k goes in another file. Okay. So lesser than k goes in one file and so on. So this is the logic that we have created. Now let me just enable this logic by going into driver and uncommenting this piece. So here we are specifying our custom partitioner. By default, it uses the internal partitioner. Okay, I'm going to go again there and would move this to Java MR out, the older one, to say Java 2 reducers. Okay. So we have Java 1 and Java 2, and now I'm saying and jar. So default partitioning does kind of round and round, but it won't take one key to different places. Okay. Otherwise, whole grouping logic will fail. So now let me just try to run the same Hadoop jar command and see if the partitioning is happening in a different way. Okay. Ant is similar to make. That's right, David. That's correct. It's actually designed exactly like make. If you take a look at, instead of make file, they have build.xml, and you will get a complete picture. Great. And so now let me go back to Hue. Let me just open this folder in another file, another tab, and here I go. Okay. Now you're going to notice something here. Part 0, part 1. So what you see is now this time it has this kind of model, right? All the things up to k are here in the first part. Okay. You can see up to k are in this first file, right? And k onwards are in second file. Yes, it goes by ASCII value in that logic. Great. So we created two files this time. Now, if we concatenate in this one, if you concatenate these two, will we get the sorted results? Right? This time, because these two ranges are non-overlapping except for this one we can, I think, get rid of. Okay. Except for that, if we just concatenate the part 0 and part 1, we will get the results, right? While in the other cases, if we try to concatenate these, we'll get the wrong results. Question from Noor is, if we have the same partitioning logic and we have 3 reducer, then what will happen is the third file is going to be empty. Therefore, we have to design here. We have to make sure to return 0, 1, 2 instead of 0, 1, 3, instead of only 0, 1. Okay, good question. So, all right. So I hope everybody's clear about this. A question from Mita is, which one is input file executed here? Come again. The input file, the entry point, do you mean, or the input directory? The input file in which contains the word count data. Right? So let me just show you. So here, this is our entry point, correct? This is our entry point, step driver. Yes. And if you go up here in this step driver, you will notice that here we have hard coded the name of the file somewhere. Is it visible? Yes. This is where we have kept the input file. And where will it be? It will be in the HDFS. So we'll just go to CloudxLab Hue, okay, d.cloudxlab Hue, and go to file browser and go to we'll just edit the path and copy paste this location. Okay, this is where we have kept. Okay. All right, is this what you're looking for, Binta? This is the input data that we are trying to do the word count on. Great. All right, so this was a quick overview, and instead of if you really want to write your own programs, you can generally write just following these principles. You can just copy this word count folder into your own folder, and then basically tweak the logic of stub mapper, stub reducer, and stub driver, and then start working on that. Okay, so I think that this could be a good starting point. Instead of writing the entire logic by yourself, you can just start using this. All right. So in case you are not, if you really want to do MapReduce with Java, but there are alternatives. Let me talk about those alternatives. Okay. So here, if you go into the course, and there you will not notice the MapReduce programming. Take a look at this one. This should give you a good overview. Okay. If you really want to understand how it works in Java, then take a look at that. All right. So that was quick hands-on, and that's pretty much with MapReduce 1. Now, we did not like much about Hadoop MapReduce in Java because just there was too much of code, right? So what Hadoop guys did was they provided something called Hadoop Streaming. Okay, should I move on with Hadoop Streaming? This is for the programmers, or this is for the engineers coming from all backgrounds, not only from Java. All right. Is anybody stuck somewhere, or Sure. Noor's question is, can you please run through an example with Python also? Yeah, we'll see if we can go through. There's a Python code there. You can take a look at that. That should give you an overview on how to do that. Okay. We'll talk about the Python code in this Hadoop example. Okay. And trust me, you will not have problem at all. Okay. All right. So should we start? Okay. So I don't see yes from everyone. Or maybe some of you have gone to sleep or something. I can see Prashant is awake. All right. Okay, for Prashant, it would be, I think, 12 o'clock. Okay, I see. All right, yeah. Yes is the default logic for any. Okay, good, good. So yes, so this is going to be simple and interesting. So remember we did some exercise using Unix command, correct? The sort command, Hadoop, fs sort, and so on. Hadoop streaming actually make entire thing look like a sort command. Okay, so Hadoop streaming is nothing but a special jar somebody created for us so that we can pass our own programs which can be run as mapper or reducer. Okay, so why? Because Java MapReduce is cumbersome. Let's accept this. And legacy code cannot be run as mapper or reducer using default one, because in lots of organizations there's a lot of legacy code and it's impossible to kind of translate that code into Java. Okay, I mean, you'll be amazed to know that at Amazon we had a lot of code in Perl. Okay, and it was really difficult, and there are many non-Java programmers. Okay, so the first two problems are far bigger for me, because the even if somebody learns to do the Java programming, it's still the overall time consumed in writing MapReduce was really high. Okay, so that's why. Okay, also keep in mind that what is not Hadoop streaming? Hadoop streaming is not equal to real-time data streaming. It is not about processing data continuously. Hadoop streaming is not. Hadoop streaming is more like the Unix sort command. Okay. Here, all you have to do is write one program, write or wrap one program, which can give out key value pairs. Okay. Key and value should be separated by the tab. Okay. And which reducer, which will get the key and value which are sorted. Here, notice that Hadoop streaming does not sort it unsorts the data. Okay, Hadoop MapReduce will sort the data, Hadoop streaming will unsort the data, and the data that you will get is ungrouped but sorted key value pairs. So Hadoop streaming behaves just like sort command. Okay, so here is a simple example. Okay, so this is what we are going to run very quickly. Okay, I think this I can close probably. I'll just minimize this. Okay, so here we go. I'll just convert it into single line. Okay, and here. All right. All right. So what is it that we are saying? We are saying Hadoop jar, instead of providing our own jar, we are providing Hadoop streaming's jar. This is the program that does the entire magic. So this is shipped with the Hadoop. We are providing an input folder, and then we are providing the output folder. And here is the mapper command. Okay, the mapper is nothing but our Unix command. Here we are providing the Unix command as mapper. Okay, so the way we discussed earlier, that for Hadoop we provide the mapper, the command, right? Instead of providing our programs, we just provide the binary. Now here we are providing the Unix command. The SED is already installed on all machines, so we don't need to install SED. And reducer is this command, right? If you remember, in case of our Linux word count, what we did was we did cat my file, then passed to SED, then sorted the data, then passed it to the reducer, to unique. Correct? What was our actual command? It was something on the lines of cat file pipe to SED, right? Then we did sort, and then we did unique. Correct? So the role of cat file as well as sort is taken by Hadoop streaming. We are only providing SED, and we are only providing the reducer. Okay, so we are going to execute this and then see if it works. Okay, So you also all can try the same thing and see if it works. So it's going to create the output in this folder, right? Also notice that we have only provided the folder. In case of input, you can provide the folder or the file. It's the same thing. Again, it is giving some kind of strange error. Number of private slash container E31 dot tokens could not find a valid local directory for this. Could not find a valid local directory. I'll just keep this log so that I can take a look at later. Okay. Okay. Now it failed, right? Failed reduce task are these many. So I'll have to delete this RMR. Execute it again. I'm hoping that this time it will work. Good for Noor, it worked. As his substitute, I believe. That's right, David. Okay, so let's let it finish. Now this is the okay. So I hope this time it worked. Let me just go up. It says launch this, and so on. Perfect. Okay. Now that was the easiest way to get our work done in MapReduce. You can click on home, go to that directory. Okay, so I can just click on home. No need of editing the path. Here, I can do order. Okay, so you can see that there are, so this file has been created, right? The word count has been done. Though the output is not that clean, but the word count is done. Okay, why output is not clean? Because we have not cleaned it. We have only substituted space with new line and called the reducer. Okay, so there should be a folder called word count output underscore Unix. In that you will see this. Noor, did it work for you? The output folder, if you do not specify from slash, okay, that means it is in your home folder, relative files, right? If you specify using slash, then it will be absolute folder. If you don't specify slash before your output, it will be appended. This path will be appended. Your home directory will be prepended to it. Otherwise, if you say slash word count, it will try here and it'll give error because you don't have permission to do there. Okay, so it should be you go to Hue, click on home, and then you should see in your home directory if you order the data by the date. Okay, great. So a question from David was, please remind me of /g in case of SCD. /g means global. Okay, /g means global. Done? Okay. A question from Noor is, but with this approach, if you have a complete logic of MapReducer, then you have to write everything in bash file, right? And which would be more complex than Java? Not really. So let's say if your program can run from console, you can run it from here, okay? So any program that you can run from the bash, you can run from Mapper, okay? So whether Python or anything. So not always the bash. A question from Hitendra, I can see the output file. Subhu's question is, can you give some real-time examples where we can use MR? So MR is used almost for everything, okay? Uh, it was used almost for everything where the data goes beyond small size, okay? Where did I use MR personally? In case of, let's say, InMobi, when we were churning a lot of data in terabytes, specifically the log files, because log files were around 200 terabyte data, which we were doing that time. So we were writing these Python code, which would basically clean up the log files, and we were all executing that Python code using this kind of a syntax. Okay, using this kind of syntax. Now, that was one such example. Similar thing could be done for other cases where the data is really huge. Okay. A question from Sachin is, can you explain what did, yeah, that we will cover very soon. Okay. We'll talk about that part now. Okay. So here we are. All right. So this small command, this one line command was our mapper. This two words command is our reducer, right? We did not have to create any file. We did not have to compile anything. We just specified these two commands, and that basically did the word count. Now, right? So in the first line, we are saying Hadoop jar, this is the jar that contains the logic of Hadoop streaming, which will actually do the work, and which will execute these for every record. And this is our input directory, this is our output directory. Now, what's happening inside it? Okay, what's happening inside it is the Hadoop is behaving like a big sort command. Hadoop is behaving like a big sort command. Okay, so this is our input data. This is the file. Let's say that it contains only one line for now. Okay, then we are feeding it here. We are saying replace space with a new line. Okay. Here we are saying SCD substitute space with new line. So what happens is it gets converted into this. And we said that mapper should give key value pair, right? And there is no value here, right? So here in case it's just assuming this value to be null. Okay. And what Hadoop does is whatever you give the output, Hadoop streaming will take it and order it, sort it. And then unique-c will find the unique in it. The only problem unique was having is it does not sort the data. It expects the data to be sorted, only then it gives the correct results. All right, so this is our input file, then we replace space with new line, and then we sort, this Hadoop sorts the data for us, and then we call unique-c. This is very similar to our Unix pipeline that we talked about earlier when we were talking about the word count in general. Just that instead of sort command, Hadoop is the sort command. Okay. If you have multiple reducers, this is what is going to happen. Some of the keys are going to be here, some of the keys are going to be here, some of the keys are going to be here, and your unique command is going to be executed on multiple machines. Okay, now let's say we want to do the cleanup. So we'll just create one script. Okay, we'll just create one script, and this kind of script could be created for any program. So here I'm going to walk you through Unix shell script. Okay, I'm going to walk you through a Unix shell script. So first of all, okay, what is the best way of editing this file? Best way is going to say Jupyter. Okay, going to Jupyter. Where is my Jupyter? This is Hue. I'll just close these Hue files. We are done with Hue. We'll just keep one tab open for you. Close this Java. We'll just keep this Jupyter up. Okay, go to my home directory, right? Go to my home directory. Okay. What happened to Jupyter? Okay. Now, this is my home directory, you see? Now, what we're going to do is we're going to say new text file. Good. In this text file, we're going to write this. Okay. In this text file, we're going to write this. Okay. Inside Jupyter, we are basically creating a new file, and let's give it a name. What name would you like to give it? I'll say mycmd, or say word count. Okay, let me just share the slides. The slides would be there, right? In that. Okay, let me just share the slides. Okay, now, so I'm just saying word cnt.sh, or we'll say word cnt underscore map.sh. Okay, please note that this generally the shell files, okay, or generally any file that you create in case of Unix, it tries to figure out how to execute a particular program by the first line in the file itself. So here we are saying that this program will be executed with bin bash. Had this program been Python, we'll just change it to bin Python. Okay, we'll just change it to user bin Python. Okay, so had it been our Python script. Also notice that in case of Unix, this extension of the file does not matter. The way Unix figures out is how to run a particular file is by the way of the first line. So here I've just saved it. Now I'm going back to the terminal. Going to my home directory. Just check if what is the status of this one. Okay, it is there. Good. Now, next thing we are going to do is we're going to change its mode to executable. Okay, change its mode to executable. Keep this in mind. Otherwise, if we did not change this, it'll give error, because you should be able to run this locally. Let's say echo this is a line, and I pipe it to this particular program. And I'm saying / because it is in my current directory. Okay, so we are able to run it. So what is it that we are trying to do? We are trying to create our own script or our own program which can run perfectly fine. So we are taking a practical case. Here, what does this script do is, whatever input is provided to this script, it first of all replaces spaces and tab, any number of spaces and tabs, with a single new line, right? Then what it does is it removes everything which is not A to Z. This means not. this caret character inside square brackets? It means not. We're saying that replace anything which is not alphanumeric with nothing. This means nothing because there is nothing between these two slashes, and do it globally. Then we are saying whatever is the result of all of these two, the output, we are saying translate capitals into small. Okay, so here we are substituting a space and tab, any number of this with new line. Okay, new line as in enter. When you press enter, the new line occurs. So that good. So you can test this out with this kind of way. Okay. Now, the next thing we're going to do is we're going to execute this using Hadoop MapReduce. So what are we trying to do is not really, Hitendra, anything that you are able to execute like this on the Unix cell, because in Unix cell you can execute Python, you can execute anything. So you could write this program in any language. If it can execute inside Unix, then you can use it. Question from Mintao, why is there no space between slashes? Because we want to delete that character. Okay, so if you can take a look at it. If we are saying asterisk brackets, okay, I'll just put some special character. So we are putting these special characters, so it is deleting those. Okay, so that's what we are saying. Replace anything which is not alphanumeric with nothing, right? Good. So we can see that we are able to test our mapper locally, and this seems to work fine. Okay, so we did two things. One is we created this file, then we changed the mode to it, and then we tested it. Okay, then we tested it locally, and then we are going to execute this command. Okay, so first of all, we created this file. Instead of this mycmd.sh, we created word wrdcnt_map. Okay, and then what we are going to do is we're going to execute this. Okay. All right. So here we are saying that Hadoop jar, same thing as we did earlier. Okay. And then we are saying that number of tasks is 2 this time instead of 1, and input file remains the same folder, and output is word count clean Unix. So let me just delete this if it is existing already. So I'm saying Hadoop fs rm-r. It is not there. Now we are saying this. So what was the name of the file that we did earlier? The name of the file was this. Good. And then the reducer command remains unique minus C. Similarly, we need to change the file name that we are passing here. Okay, let's do that. Is it working? It says the could not find a valid local directory. Wow, the same problem again. Sure. Okay. So the first of all, we created a file using Jupyter, and we copy pasted this content into the file. Okay. We copy pasted this content into the file after bin bash. It failed. It says completed successfully. Okay. Okay, so let's take a look at the outcome. All right, let's go to my home directory. Okay, so here you can see that there are two folders, two files now, right? Correct. So basically, we are able to execute the MapReduce very seamlessly without having to worry about writing the Java code. Okay. So here, what we did was we created a shell script. Okay. We created the shell script. A question from Sachin is, Hitendra is, can we take a look at the output of the web console? Yes. So this is the one. You can just scroll up and take a look. Okay, good question. Then, yeah. So I'm going to talk about this more in detail. So this is what it is. So question from David was, what is tomorrow's agenda? We will start with Hive tomorrow. Okay. All right. So here, why we are passing the dash file command here. Dash file, we are saying, because this command which we are passing to mapper, the command that we are passing to mapper is not existing on the server. It's not existing on the server. Therefore, we are shipping it. Dash file means ship it. So had it been your Python py command, you'll basically first change its mode to executable, put user bin Python at the top, and write your entire code exactly in the same way. So this mapper command, this script that you're writing, it will get the input as the standard input, right? So you'll just have to keep on reading the data from standard input and write to the standard output the key space or key tab value. All right, that's how it happens. So if you want to know more about streaming, you can take a look at it. Okay. So here is one documentation about a question from Sachin. How do we implement max temperature with Hadoop streaming? Okay, you can simply implement the max temperature in the same way, right? So here, let's say the code we actually wrote here, you can write simply in Python. So you could take this piece of code. Okay, so here line will be the line, you will write the line from read from the std input. Okay, so you'll say here for, okay, I should not be bothering this one. So this input to your mapper is coming from standard input. Okay, so you will be writing in your main program for I in, for lines in, line in std in, and this is what you will do. That's it. Okay, and here you need to print /t followed by this. Okay, so that should be good enough. This should be a mapper. A question from Hitendra is, I could see the output file in Hue. How to see it in web console? You can use Hadoop fscat. Hadoop fs-cat, that should do that. Okay, so if you want to take a look at the other example of Python, you can take a look here. So here, let's say character frequency we have done. So there is an example where we are counting the character frequency. So all we do is we call the main method, and here we are reading from the standard input, and all we doing is this. Okay, so that's all. So you just write a program which reads from standard input and writes to standard output. And similarly, reducer will get the input data as the standard input and do the standard output. Okay, so that's all you need to do. Okay. And it's quite easy to just test out your Hadoop streaming job. Why? Because you can just use the sort command between the two and test it out. Okay. A question from Grishma is, above is used to remove spaces before calling mapper function? Yes. So above is used. No, the mapper function itself is removing the.
Uh, Hi Sandeep, I meant to say the command file word count underscore map dot sh.
Mhm.
The stream editor, this command, the file where we have the stream editor, will it be
Mhm.
used before sending the data to the mapper logic?
Which one? This one, right?
Yes, yes.
So basically, this is the mapper. This mapper basically is internally calling these three programs. So Hadoop will Hadoop will basically read data from the input file, pass it
Okay.
to this command. This
Okay.
command is going to execute these three commands in the chain. Whatever is the input data coming, first it will replace the space and tab, then it will remove the non-alphanumeric characters, and then it will translate uppers to lower, and that's all. Okay. So basically, it is converting the input lines into the text, into the one word per line, and also cleaning up each word.
Okay, I'm just confused here because we have two components here. Mapper, for the mapper, we are using the same file, and even for the file option, we're using the same shell script.
Right. So what we are doing is here, earlier we did not use file command. You remember that?
Yes, yes, I remember.
You know why? Because the mapper command
Mm-hmm.
was already existing on all the machines. We did not need to copy that, right? So this logic that you are writing here is going to be executed somewhere else, right? Not on your E or F or G. It is going to get executed on A, B, C, D, or maybe E, F, G, H, right? Therefore, earlier this SCD command is a default Unix command. It's already there. Therefore, we did not need to ship it. But this new file that we created just now, is not existing elsewhere.
Okay.
That's why we are shipping it by using the file option. So if
I got it. I got it.
if let's say you are using Python program and your Python program is sending emails to people, now you want that email program to be in the same folder where your Python program will run, then you will use this file command. Okay,
I understand.
great, wonderful question. Okay, so all right. Now, question from Noor is, so we have to always read from standard input and write to the standard output. Yes, that's why it is called streaming, exactly. So SED command is called stream editor, those who are not aware. So this Hadoop streaming is designed on similar principle as the Hadoop SED, right? That it'll take the input and will do the output from standard input. That's why it is called the streaming. Okay, so we always, right? Now, question from Minta is, what is the function of SCDR? R means use the regular expression. R is used for regular expression. Okay. So if your data this contains regular expression, you generally put R. Okay. Otherwise, it would not work out. Good. Now, a few notes before we, right? Or we'll continue from here tomorrow. Question from Subbu is, how to remove output? Can you show that once again? So you can just go to Hue and rename that. Is that your point? Or you could use this command, the one that I used, Hadoop fsrmr. Okay. All right. So wonderful set of questions. We'll continue from here, and tomorrow we are going to work with Hive. A question for Hitendra, many steps in jar execution shows failed. Okay. So the job should not fail at the end. That is the one thing, because it would try on multiple machines. If it is failing, it does not completing. That means maybe you have not changed the mode. You have not done ch mode plus x. Okay. All right. Question from Noor is, so we either use Spark or Hive for big data. So for processing, we generally use Spark, but for backward compatibility reasons, MapReduce is also quite useful. So the MapReduce with Java, you don't need to go more detailed into that. Okay, but if you want, you can just take a look at the examples. Examples mostly cover everything that is required. Okay. All right, so that's pretty much. Any other questions do we have? But most of the computation in big data domain generally happens over either Spark or Hive. Okay. Big, and even streaming is useful. Many people use streaming also because it's quick. And but people, those who are really building a framework or a platform, they only use the MapReduce Java one. They are built upon the MapReduce. That's right. Hive and streaming both are built upon MapReduce, while Spark is a separate product altogether. It's from a separate company and it doesn't use Hadoop at all, Hadoop MapReduce at all. Question from Aniket. How is Hadoop streaming different from Kafka? Say Kafka is a queue and Hadoop streaming is nothing but MapReduce job. Okay. Streaming does not mean that we are going to process the continuous data. Here, in case of Kafka, when we say streaming from Kafka, there it's continuous data. Here, it's not continuous data. Here, basically, it's another way of getting your work done. So streaming here, in case of Hadoop streaming, is kind of misnomer. Okay. A question from Noor: MapReduce is a concept, or it has different concept to process distributed file? So Spark has a completely different concept, while Hive has the same concept as MapReduce. Under the hood, it uses the MapReduce. Okay. Spark has a bit different concept. All right. Good. Good. So that's pretty much for today. We'll continue from here tomorrow, and we'll start Hive tomorrow. Okay. And have a good day. Thank you. Good night. Have a good day.